Here is an example for how you do one very simple Boolean function. In this case, we're going to do this Boolean function, x and y or z naught. All right, so first thing we need is to get a board. So we're going to need a board like this. And then we're going to use some batteries. We're going to need 3 because these circuits are working with 5 volts. So we're going to use 3 batteries in series. That's going to be 4.5 volts, but it should be sufficient for our purposes. Now we're going to connect these batteries like this in series. Okay, this one was not good. I need to have it there. And then from here, I need to draw another wire. So click on the beginning, click at the end. Then I'm going to connect this one to the red channel. Remember, all this channel is connected from here to here. That's why when I hover over it, it highlights the whole channel. Similarly with this. However, these channels, as you see, they're highlighted vertically only from here to there because only these are shorted together. All right, and then I'm going to take the negative and the ground, that is, click, click, click. Okay. If I want to use these other channels, I can connect them too. So click, 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 and click. Then over here, I will take this one and connect it to this channel. And I'm going to make these black just to distinguish. That's it. All right, so I have now wired my board. What I'm going to need now is the chips that I'm going to use. I'm going to need to get the logic end chips. So I'm searching for an AND gate. So I have a quad AND gate right here, the 7408. Click on this, and I need to go and put it, I'm going to put it right here. All right, now I need to power this chip. And remember, the power is this pin right here. So click, click, and the ground is this pin. So click, click. All right, now internally, these chips are containing a lot of different gates. And if you remember from the schematics, which you can review if you would like, this one is input to the first gate, gate A. All right, this is input. This is input, excuse me, um, input gate 1. Okay, input A, input B, and then this is going to be output of gate 1. All right, so I'm going to use 2 wires to represent the signals X and Y. All right, so my signals X and Y will be, let's say, right here. I'm going to use these 2 channels for my signals X and Y. So this is going to be X, and I'm going to hook it to 1. This is going to be Y. I'm going to also hook it to 1. And if I want, I can add the label to label them, but I'm not going to do that right now. The only thing I'm going to do is just change the colors. I'm going to make one blue, I'm gonna make the other one, I'm gonna make it I don't know, purple, and I'm gonna need a third signal for the Z, which is gonna be this one, and I'm gonna use this one here. I'm gonna hook it to 0, and I'm gonna make this wire a orange. So that way I have my 3 signals, and I can switch them from 0 to 1 and 1 to 0 by just switching the places here. Now this first two, I need to end them together. I'm gonna use this AND gate right here. So I'm gonna make a connection from this pin to this pin, and I'm gonna make a connection from this pin to this pin. Okay, now the output of this gate is this one. Okay, remember this. The last signal, the Z, I need to invert it. So I'm gonna need an inverter. So let's look for a NOT. Well, that's not gonna work. Inverter. Invert. There it is. Hex inverter. I'm gonna take a 7404 and I'm gonna stick it right here. I need to put wires to power it. So from here to power and from here to ground. And then I'm gonna use an inverter. This one has 6 inverters in it. So here is the inverter 1 with input 1 and output 1. Here's inverter 2 with input 2 and output 2, 3, etc. So I'm just going to use the first one. So I'm going to need to hook this wire to this. And now the inverted output is going to come out here. Now what I need to do is I need to OR these two together. You know, this one and this one. So I'm going to need an OR gate. All right, so I'm going to take this one. Now there is an XOR gate, but you're not supposed to use this. Remember that. So I'm going to use this one, which is a quad OR gate. I'm going to stick it over here, always on this channel. Remember, I need to power it. So power from here to here and ground from here to here. Okay, I made a mistake on this one. This signal, no, I didn't make a mistake. I needed to take this signal and I need to invert the Z, this one. Let's make it orange too. There you go. So the Z signal needs to go over here to make the inverter. Now this one has inputs, gate 1, input A, input B, and output. All right. So I need to take this output from here, output 1, from here, stick it to this input. All right, let's make this one a turquoise color so that we can distinguish things. And then this one here, I need to stick to the second input, which is this one. Let's make this one a pink. And now this is my total output. All right, this is my total output. This is the one that I need to display. And in order to display this, I can hook an LED. I have 2 channels right here. I can put the LED on. So I'm gonna get my LED here, and I'm gonna stick it right there. I'm gonna need to put a ground on it, and then my output signal, which is this one, will have to go to the input of the LED. Now I do need a resistor in series with the LED, so I'm gonna stick it to the ground like that. Okay. All right. Now simulation. What should this produce? These 2 signals, the X and Y, are 1s, so the AND gate should produce a 1. the total output should be a 1. Starting the simulation, and my LED does not light up. That means that I have either made some mistake, or my LED doesn't have the right polarity. All right, so I believe that it's probably that it doesn't have the right polarity. Okay, so select this one and then move it, and then select this one and move it. Start my simulation, LED lights up. Okay, so the ground actually goes on the straight pin, not on the slanted pin. Okay, so stop the simulation. I can change these like that. Well, this doesn't work like that. I have to select this first by clicking on it, then move this one. Okay, and then if I start the simulation, the LED lights up again because the Z is hooked up to 0. With the inverter, it becomes a 1. The OR gate will produce a 1, and that's the end of it. Now, you can share this, and I'm going to just turn this into the public domain and send you a link so you can see it. That's it.